Well, hey guys, I'm sitting here making the week 5 tasks Monday. You got a quiz, and I'm making your quiz. And I thought, hey, I have got to make an Ed puzzle video for the next section. So each week we're gonna try to do 2 sections, right? So I made an Ed puzzle video for section 2, 3. All right. So now we got to make one for 2-4 deductive reasoning. Okay, so let's gear up. Remember, we've changed course. First, I was like, no Ed puzzle videos. You got to do it all from the book. And then I was like, all right, I'm going to be out. So we're going to need Ed puzzle videos. So for the time being, we're going to do some Ed puzzle videos, and the purpose is to help you with the green questions. And, might be a good thing to do throughout the year too, actually. So let's scroll on back to section 2-4. And remember, before you watch this video, if you haven't done the yellow section in the textbook organizer, stop, pause the video, and do the vocab. Because otherwise, when I'm using the vocabulary, you might be like, what's he talking about? All right, so here we are, section 2-4, deductive reasoning. And so we're going to do real world example number 1. So this is about differentiating between inductive reasoning and deductive reasoning. So inductive reasoning, the thing that we're going to use to distinguish that is something that follows a pattern used to draw conclusions. It's like that. All right. Okay, so you use a pattern to draw your conclusions, then you are using inductive reasoning. But if you use laws of logic to draw conclusions, that would be deductive reasoning. All right, so let's draw a little arrow to that. Deductive reasoning. Boom. Okay. So let's go ahead and all the signature items on the restaurant's menu shown are noted with a special symbol. Kevin orders a menu item that has this symbol next to it. So he concludes that the menu item that he has ordered is a signature item. All right. So that seems a little tricky, okay? But it is okay, let's go ahead and read I'm thinking it's deductive reasoning, but let's look at the examples one time before we make that conclusion. Every time Katie has worn her favorite socks to a softball game, she has gotten at least one hit. Katie's wearing her favorite socks to a game tonight, so she concludes that she'll get at least one hit. Katie is basing her conclusions on a pattern, there you go, of observations. So she's using inductive reasoning. All right, so that's the pattern, right? If John is late in making his car insurance payment, he will be assessed a late fee of $50. John's payment is late this month, so he concludes that he will be assessed a late fee of $50. That is a rule, okay? So it's a rule given to him by his insurance company. That's deductive reasoning. So this is a rule that the restaurant has made that if a menu item is special, if it signature, then we will denote it with a special symbol. And so Kevin orders a menu item that has a symbol next to it. And so he concludes that it's signature. So this is deductive reasoning. He's using a rule there. Now let's see. Hopefully this next one is inductive. Hopefully there's a pattern. None of the students who ride Raoul's bus own a car. Ebony rides a bus to school, so Raoul concludes that Ebony does not own a car. Okay. That is inductive reasoning. Well, now hold on here. None of the students who, oh man, that is deductive reasoning because it says none. So there isn't, it's not like Raoul notices that 5 people on the bus don't own a car. And so Ebony is also on the bus, so he thinks that she won't own a car as well. It says none of them own a car. And since Ebony's on the bus, that's deductive reasoning. She must not own a car. So let's look back at the signature items and see if we can use that same law. All of the signature items have a special symbol. Kevin orders it, it has a symbol. He concludes it's a signature item. So they're both deductive reasoning. All right. So because that was not an inductive reasoning, let's go ahead and go to the check your understanding and let's see if one of these is inductive. I'm sure that one is. Holly notices that every Saturday her neighbors mow his lawn. Today is Saturday. That's inductive. It's following a pattern. Now it may or may not happen, but there's a pattern here. It's Saturday. I think you're going to mow your lawn. You did it the last 5 Saturdays. So that is inductive reasoning. There's a pattern. So hopefully that helps you. Now let's go to example 2. Okay. Example 2, the law of detachment. So the law of detachment is right here. And so remember, with a conditional statement, we have 2 parts, the hypothesis and the conclusion. Okay, the law of detachment says if you are given the statement, a statement that is the hypothesis of a conditional statement, then you can draw the conclusion. Okay, so if you're given the conclusion, you can't draw the hypothesis. That's invalid. But if you're given the hypothesis, you can draw the conclusion. All right, so let's explore. Okay, if 3 points are non-collinear, that is the hypothesis, then they determine a plane. Okay, so if we were told that we had 3 points that are non-collinear, then we could say they determine a plane. But here we're given the statement that blah, 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 lie in a plane. So this, and then drawing the conclusion that they're non-collinear, no, this is invalid. It's backwards. You cannot make the conclusion that's the hypothesis. You have to make the conclusion that's the conclusion. All right, it's much simpler than that. So this is invalid. Okay, this one, I sure hope it's valid. Okay, if a student turns in a permission slip, then the student can go on the field trip. All right, hypothesis, you turn in your permission slip. Conclusion, you can go on the field trip. Felipe turned in his permission slip. Conclusion, Felipe can go on the field trips. This is valid. Okay, so we were given the hypothesis, and our conclusion is the conclusion of the conditional statement. That is the law of detachment. My favorite law, though, and we're going to skip example 3. You'll be glad to know. Not that it's bad, but you know, we're going to move on to the law of syllogism. Favorite law. All right. And why? Because all mathematical proofs are syllogisms. They go from one statement to a conclusion, and then that conclusion is the new hypothesis, and then we draw a new conclusion, and that conclusion becomes our next hypothesis, and we just keep going down, down, down until we've linked an original hypothesis to a down, down, down conclusion to make a brand new conditional statement. It's great. Okay, so let's look. If P implies Q and Q implies R, then cross out the middleman, P implies R. Okay, it's like the transitive property of logic. All right, so let's make some syllogisms here. Okay, determine whether a statement follows logically from the given statement. If you do not get enough sleep, then you will be tired. If you are tired, then you will not do well on the test. Okay, we have our two conditional statements. So our syllogism would be, let me use my text box here. Our syllogism would be, if you do not get enough sleep, then you will not do well on the test. You see? So the original hypothesis and the last conclusion become a new statement using the law of syllogism. Okay, so now let's see if we have some logic. If you are tired, then you will not get enough sleep. Okay, no, that's backwards. It might be true, but it's backwards there. If you do not get enough sleep, oh, that's our original hypothesis, then you will not do well on the test. Yes, that is exactly what I said. That's the law of syllogism. If you do not do well on the test, okay, that's a conclusion. We can't start off with that one. Then we can't go backwards. That's backwards. There's no valid conclusion. What? No, G is right. Okay, all right. And last one. Okay, so apply laws of deductive reasoning. So now, either there's two laws, the law of detachment and the law of syllogism. So the midpoint divides a segment into two congruent segments. If two segments are congruent, then their measures are equal. M is the midpoint of AB. All right, so where is our conditional statement? It's right here. If two segments are congruent, their measures are equal. Oh, and also a midpoint divides a segment into two congruent segments. So we could change that into a conditional statement. If a point is a midpoint, then it divides a segment into two congruent segments. And then the second one, if two segments are congruent, then their measures are equal. All right, given M is the midpoint of AB. Okay, so M is the midpoint of AB. So that is our original hypothesis. A point is a midpoint. So we can draw the conclusion using the law of detachment that it divides a segment into two congruent segments. and using the law of syllogism, because this conclusion is the hypothesis, then the measures are equal. So we can say is, using the law of detachment, we can say two congruent segments. So we can say AM equals MB. But then we can also draw, and we can write law of detachment. We can also draw another conclusion using the law of syllogism. Oh, I kind of just did the law of syllogism, didn't I? Because I said their measures are equal. Okay. I don't have a congruent sign. So is congruent to MB. That is the law of detachment, because that is the first conclusion right here, two congruent segments. The second conclusion is that their measures are equal. That's the last conclusion right here. That's the last conclusion. So that would be the law of syllogism. All right. So we could totally talk about all your questions in class. I just wanted to give you a rundown for your green section so that we don't have to do all that in class. Then we can start with your questions. All right, see you there.